Hi, I'm Ken Christensen, and I'm a product manager in the Power and Energy Division at Keysight.
And I'm Blake Vermeer. I'm an R&D firmware engineer here at Keysight as well.
In the next few minutes, Blake and I are going to give you an overview of the IntegraVision Power Analyzer. The IntegraVision Power Analyzer is a purpose-built power analysis instrument that has 0.05% accuracy and 16-bit resolution. With this single instrument, you'll be able to see, measure, and prove the performance of your designs. First thing we're going to do is give you a tour of the connections on the back of the instrument. As we look at the rear of the instrument, the first thing you'll notice are the two power channels. Unlike an oscilloscope, a power analyzer power channel has both voltage and current connections. For the voltage connections, we use banana plug connectors. And these connectors are up to 1,000 volts RMS. The current connections come in two varieties, either our direct connection or a BNC connection for external probes. The direct connection has both a 2 amp and a 50 amp connection. Then those go through a shunt that's built into the system. If you have currents that are higher than the 50 amps, you'll move the slide down and you'll expose the BNC connector for the external probes. And then as we circle around, we have both trigger in, trigger out, and a 10 megahertz clock signal. All of these are with an SMA connector. We deliberately made these different than the BNC connector so that you can't mistakenly connect a BNC to one of these other signals. And then finally, we have a LAN connection and a USB connection. With the LAN connection, you can actually use our remote front panel software to control the instrument from a distance. If you have some type of concerns around safety, around either the current or the voltages, you can physically be further away from the instrument and still have full control. So now let's move around to the front. When we look at the front of the IntegraVision Power Analyzer, the first thing you'll notice is the large 12.1-inch touchscreen display. We have voltage, current, and power all displayed on a single screen. You can see channel 1 is in yellow and channel 2 is in green. On the right side of the instrument, you'll see a number of knobs that look like any oscilloscope. In fact, if you can use an oscilloscope, you can use the IntegraVision Power Analyzer. And now Blake is going to show us the setup of the power channels.
So now I'm going to give an overview of the channel menus. If we go into channel 1 here, we can change the coupling to be either AC or DC coupling, enable or disable anti-aliasing, and we can have control of the current inputs. If we have a current probe hooked up, we can set the ratio and the offset for our probe. The last major control we have under the channel menu is ranging. We have either automatic or fixed ranging. Fixed ranging is best when you're trying to capture small transient events that may not be picked up by automatic ranging.
So Blake, now can you show us the triggering?
Yes. So a triggering menu, we can select what source we want to trigger from. It can be any of the voltage, current, or power signals, an external trigger, or line trigger. And for the edge, it can be either rising, falling, or either. We can also change the trigger mode to be either auto trigger or wait for trigger. In addition to this, we have our normal single trigger mode that you can switch to as well. So now we're going to talk about the continuous whole cycle analysis mode of the IntegraVision Power Analyzer. So if I go into the CWA mode, we have 4 different major categories of stuff we can measure. We can get basic power quality measurements on our waveforms. We can measure harmonics of our waveforms. We can measure energy over time of our waveforms. And we can also measure the real-time efficiency. Our first major menu is the power quality menu. We can measure AC voltage, AC current, DC voltage, DC current, instantaneous power, power factor, crest factor. And we can also change the mode to be DC only mode, and we can see the ripple on our DC power supply if we were using one to know how good of quality power supply it is. Our next major mode is harmonics. In harmonics mode, we can measure the THD of our signal in real time, plus at 60 Hertz frequency, we can see the individual powers of the first 200 up to the first 250 harmonics. After our harmonics menu, the next thing we can do is energy measurements. In this case, we can set up how long we want to do our energy measurement for. Let's say I want to do it for 10 seconds. And I can start the measurement. And after 10 seconds, I will see how much power I consumed in that time. This can be configured up to as much time as you're going to possibly need for energy measurement. So our last major mode is efficiency. In this mode, we can measure instantaneous input power and output power and the real-time efficiency of our system. If our pre-built CWA modes don't meet your needs, you can build your own. If you go into the measurement menu, you can add your own CWA measurements for any of the channels and display the information that is most important for you. Another unique feature about the IntegraVision Power Analyzer is its ability to measure transient events. We have a DC switching power supply hooked up to IntegraVision Power Analyzer, and now we're going to try to capture its inrush current. So I've already set the display to be just displaying current. Now I'm going to go into the Channel 1 menu and set the ranging to fixed. This is important so we can capture the full peak of the inrush current. So I set the inrush to 50 amps and the voltage range is 200 volts. The next thing is I want to change the trigger to be triggering on current 1. I'm just going to change the slope to any and set the trigger level to a level that will appropriately trigger for this application. The other thing is too, is I adjusted the horizontal scale to be a little bit larger so I can easily capture the inrush current plus the steady state. So now I'm going to start single shot mode and see if we can capture it. There we go. So now we can see we had a huge inrush current and then gradually went down to steady state. If I go into the measure menu, I can see what the peak of the inrush current was, and I can use the cursors to measure the time of the inrush current event. As you can see, the scope-like features of this power analyzer make it very easy to measure inrush current.
You've seen this brief overview of the IntegraVision Power Analyzer. With its easy connections and intuitive interface, you can quickly get to the insight into your designs. With this single instrument and its dynamic views, you can see, measure, and prove the performance of your design.
Thanks for watching.